these first problems are asking us to determine if this relationship here is a function. And remember, a function means that for every x, there is one and only one y. So if I put 3 into my function, I get 5. Okay, that seems to work. That's good. But if I put 5 into my function, sometimes I get, or 5 into my relationship, sometimes I get -4, sometimes I get 6. No, that's not a function, because for 5, or actually for 7 as well, I get multiple different values. And for a function, for every x, there is one and only one y. So for 3 it works, but for 5 or 7, for both of those it doesn't work. So this is not a function. Let me do a better job than that. Not a function. For this one, let's take a look. Every time I put in -4, I get -7. Every time I put in -3, I get 3. Every time I put in -1, I get 2. Every time I put in 1, I get -6. Every time I put in 7, I get -7. There's no value for x where I get multiple y's, not like it is over here or over here. So this one is, yes, it's a function. Okay. Now you may notice that for this one over here, if I put in -4, I get -7. If I put in 7, I get -7. I get the same answer here twice. But that's still a function. That's okay. A function doesn't say that for every y there can only be one x. It says the other way around. For every x there can only be one y. In fact, if my function were if it were this, if it was, let's just do another one, x, y. If I say 0, I get 1. For 1, I get 1. For 2, I get 1. For 3, I get 1. For 4, I get 1. This would also be a function. Yes, it is. This is a function, yes, because for every x, there's only one y. It's only if I added another one like 4, 2, now it wouldn't be a function, because for 4, sometimes I get 1, sometimes I get 2. It's for every x, there can only be one y. It's okay if you get the same y value for different x's. So this one is a function. Yes, it is a function. For problems 3 and 4, it's asking us the same thing, except it's just using a mapping diagram. It's using a map rather than a table. Okay? And I think with the map, it's actually even easier, because you can just see right here with these arrows. For every 5, there's just one arrow going from it to -5. For every -1, there's just one value. For every 0, there's just one value. For every 1, there's one value. For every 4, there's just one value. So yes, this is a function. Whoops, can't. Function. Okay. But for this one right here, looking at -2, it's got an arrow going this way to 0. It's got an arrow going this way to 6. It's got an arrow going this way to 7. So when I put in -2, I don't know what value I'm going to get. Sometimes this, sometimes this, sometimes this. So this would not be a function. No, not a function. Yes, are these a function or not? And as I said, it means for every x, is there more than one y? And I also talked about something called the vertical line test. Can I draw a vertical line that has more than one input in it? And looking at number 5, the answer is yes, I can. For the value, it looks like -7. When I put in -7 for x, sometimes I get -2, sometimes I get -5. And I can tell that because if I draw this line right here, it goes through both these points. So the answer is no, this is not a function right here. Because of this point and this point, the answer is no, not a function. And it's not a function because it doesn't pass our vertical line test. This next one, I could draw this vertical line here, and this one here, and this one here, and this one here, and this one here, and it doesn't go through any point more than once. For every x, there's only one y. So this one is, yes, it is a function. For this problem here, it is continuous. These up here were discrete. This is continuous. But as I draw a vertical line test, it only goes through at a point one time each. So yes, this is a function. And then this one, if I draw the vertical line, let me be careful drawing it the right way. If I draw it right like this vertical line right there goes through two different points, right? It goes through this point here and this point here. So this doesn't pass the vertical line test. For this value, sometimes I get up here and sometimes I get there for that value of x. So no, this is not a function. These problems are asking us to actually evaluate the function. So it's telling me for the x's right here, for each of these x's, what is the y? So if I put in, we'll come over here, I'll make a little xy table for number 9, xy. It's asking me to put in -1, 0, 1, and 2. So if I put in -1, -1 times -4 is +4 plus 1 would be 5. If I put in 0, 0 times -4 is 0 plus 1 would be 1. If I put in 1, I'm going to get 1 times -4 is -4 plus 1 is going to be -3. And then finally, if I put in 2, 2 times -4 is -8 plus 1 would be -7. So I just have to graph these. -1, 5, 0, 1, 1, -3, and 2, -7. So these are the 4 points graphed for these 4 x's. I get these 4 y's. I can do the same thing right here. I've got an xy table. So I've got -7, -6, -5, -3, and 0. If I put in -7, -7 times 3 is -4, which the absolute value makes +4. 4 times 3 is 12. 12 minus 5 would be 7. So I've got -7, 7 right up here. If I put in -6, that's going to make this -3, which turns into +3. Times 3 is 9. 9 minus 5 is 4. So -6 and 4, which is right here. Put in -5, it becomes -2. Then the absolute value makes it +2. 2 times 3 is 6. 6 minus 1 would be 1. So -5, 1. When I put in -3, I get -3 times -3 plus 3 is 0. Times 3 is 0. And then subtract 5. So I get -5. So at -3, I am at -5, which would be down here. And then the final one it's asking, so that's -5. And then the final one it's asking is 0. If I put in 0, I get 0 plus 3 is 3, the absolute value of which is 3. Times 3 is 9. Subtract 5, that would be 4. So 0, 4. And so these are all the points for these x's right here. This one is asking me to find f of -2. So if I have f of x equals 4x plus 1, I'm just going to rewrite this, except every time I see an x, I'm going to put in a -2. f of -2 equals 4 times -2 plus 1, which equals -8 plus 1, which equals -7. So I know that f of -2 equals -7. For number 12, I just want to take f of -9, which therefore would equal the absolute value of -9 minus 2, take that whole thing minus 2. That would equal the absolute value of negative 11 minus 2, which would equal 11 minus 2, which would equal 9. So I know that in this case, f of negative 9 equals 9. Right. To solve these last two, I'm going to make an XY table to be able to graph it. So for this one, if I put in, for example, negative 4, if I put in negative 4, I chose negative 4 because I put in negative 4 here. That makes this piece 0, and then 0 times negative 3 is 0, plus 6 is 6. So I've got negative 4, 6 right here. Then, as I put in a number 1 bigger or 1 smaller, so let's put in negative 5 and negative 3. In both cases, that makes this part in here 1 and negative 1, right? Negative 5 plus 4 is negative 1. 4 plus negative 3 is positive 1, but the absolute value makes this whole thing 1. Times negative 3 is negative 3 plus 6 would be negative 3. Sorry, positive 3, excuse me, positive 3. And then if I move one additional one, negative 2 and 0, away, negative 2 is going to make this a 2. If I put in, oops, not negative 2, negative 6, excuse me. If I put in negative 2 and negative 6, both of those are going to make this 2 or negative 2, but in both cases it's going to be absolute value would make it 2. Times negative 3 is negative 6, add 6 would make this 0. So now I can graph this. So I've got negative 4, 0. At negative 5 and negative 3 go over 1 less 1. I go down 3, 1, 2, 3. So here and here. And then if I do it again, go over 1, down 3, 1, 2, 3. Over 1, whoops, sorry, over 1, down 3, 1, 2, 3. And then I can draw my lines to show what this graph actually is. It looks like this. Whoops. Sorry, okay. All right, our final one for the day is it's in the same format as y equals mx plus b. I can rewrite this as y equals negative 2x plus 2, where in that case, b equals 2 and my slope equals negative 2. And we know how to graph that. I begin by going to the y-intercept 2, and then I rise over run negative 2 over 1. So I rise negative 2, 1, 2 over 1, negative 2 over 1. And then I can draw this line. It looks like this. Oh, and this one, of course, goes down like this and this.